Hello and welcome back. My name is Corey. You're my rubber ducks for the evening, and we are working on creating a programming language from scratch, programming language named Tang, and we are using modern C++ where applicable, Bison, Flex, Google Test, ICU when the time comes, and of course our editor of choice, Vim. 100% live coding, 100% in the terminal. As I've said, nothing up my sleeves. I haven't gotten anything pre-done on this. Just starting from scratch. I mean, everything is live in front of you. Sometimes I have notes, but generally speaking, it's all live. So we can. Whoops! I've got the wrong set of hotkeys. I was trying to use the wrong set. One moment. Excuse me. Okay, so what we did last time, well, unfortunately, that was the video that tanked. What I mean by that is I recorded a 2.5 hour long video, and it was a 2.5 hour long video of the video, but no sound. And so I had to then record another video that kind of explained everything, and that was with a slideshow, and then I showed you the diff. And I don't know, maybe you prefer that, but going back to working on our language. And the goal for today is we want to get recursion and fix a few of the bugs that we know that are there. But the main goal is recursion. And so we're going to start off just to show you. If I say git log, you'll see that we indeed episode 37 was the last commit, and that is on GitHub at this moment, and nothing else is because I haven't written it yet. And if we say git status, you'll see that there's no code been pre-prepared. So everything is as basic as can be. And we want to, like I said, want to fix a few bugs. And so for the first case, I think we're going to go directly into the source for the AST node. You know what, I'm going to open test as the number 1. That's fine. Okay, and then source AST node, and which one do we need? This is going to be the function compile. Okay, so the function declaration, because that's what gets compiled into bytecode. Declaration.cpp. And on our right hand side, we will make clean, just to make sure that we're starting from scratch, and then make test watch so that it will recompile as it needs to. And let's see, if we go down to our functions, we can see here we've got our test with 0 functions, 1 function, 2 functions, and I'm going to copy the 0. I said functions, but 0 argument, 1 argument, 2 argument. I copied the 0 argument 1 just so that I can do this. And I need to copy that line. And this is, instead of P1, it's going to be P4. And I expect this to output high, high. And I think this is going to fail. Yeah, it failed because it only output one of them. And the question is why? And I didn't catch this when I was writing it. I caught it when I was doing the video that was explaining everything, and I was explaining the code. And by the way, that's why I call you my rubber ducks, because that's what rubber duck debugging is. You put an imaginary rubber duck on top of your monitor and explain your problems to it, and you magically solve your issues. It's a great way of doing debugging. Even if your rubber duck is an actual person, the person doesn't necessarily have to know anything about the code. as long as they know something about programming, usually they can ask questions like, "Wait, what is this doing? Wait, that doesn't make sense," you know. And a lot of times you come away, you solve the problem, and they're still in the dark. They don't know what what it was that they saw. And in industry, we do that a lot. Just, hey, I need another set of eyes or somebody that I can talk through with this. So, all right, so that's what I did. I figured this out. So what is happening here? What I'm pretty sure is happening is that when we run print high, it should put something on the stack for us. In fact, here, let me... yeah, I'm going to print out. So cout p4 dot dump bytecode. There we go. And what's happening is, okay, so the print high, first of all, we've got our function named print high, so that's going to get that's null value. It's just reserving the spot, and then jump to 12. So 12 is after the function. So the function is from 3 to 9, and now what it's doing is when it goes into the function, it puts the string high on the stack, which is what it's supposed to. It doesn't have any variable, so only the string high, and then load that string and print. It calls the print function, and then it pops the result, and then we return, and it says, and there's one thing on the stack you need to get rid of. So it gets rid of the high, but the thing is, it shouldn't have popped the result, because the result of print is what should have been on the stack. And we get out of there. So let's see. 12 is where it puts it creates the function on the top of the stack and puts that in stack position 0, and then of course the pop will happen, and then it reloads it, calls the function. That's the first print high. And then it's expecting it to have left something on the stack, because that's what an expression does. And remember, calling a function is just an expression. It's not until you get to the semicolon that becomes a statement. So we're expecting print high to have left something on the stack, and it now tries to pop it, and then it reloads the function, calls it again. And why is there no pop after the end? Because it is the last statement in the code block that makes up the entire script. So what's happening is, by popping this instruction number 9, that should not be there. We should have left something on the stack that could be popped later. And I guarantee if we read the error, in fact, we can do that. We can p4 dot, wait, we're going to have to do it this way, right? We've got to do the star of p4 get result. And it should say stack is empty. Oh no, segmentation fault. So maybe nothing got put on the stack. Interesting. That's fine, because either way, I know what fix I want to pursue. So this is the function declaration, and where it compiles is right here, and where I think we've got the, there we go. I added this line, and it shouldn't be there. So we're removing it, and I'm going to say, do not pop, the result. It will be the default return value of the function. And I'm too long. I'll put that in. Return statement is not otherwise used. Sure. I think that works. And see. Okay, so still didn't work. I expected that it would. Now we get to actually have a hunt for what's going on. I'm still sure that that is correct, that we should not pop at the end. What happens when we call return? You know what? Let's oops, there we go. Let's edit the source program, not dump, but execute. The reason is I want to see that return. There's our return. And I want to know what return value is. So let's just do this. Cout return value. And can I do return val dump? Return value is a null, so it does have a return value. Okay. Oh, yes. I remember the other error is this here. PC is equal to, this is when we were going into the function. We were pushing back PC, and I believe it should have been PC plus 2. Right? When we're going into the function. Yeah, because PC is the current call a function, then PC plus 1 is the argc, PC plus 2 would be the next. And that's the point of the program counter. Normally in any architecture is that the PC contains the next operand, the next value to be written. Not value to be written, the next instruction to be executed. So, anyway, all right. Going to do a compile. Hey, we passed everything this time. All right, and I'm going to go back to the previous one, and just to show you that if I add the program.add bytecode, and what I have to do, integer underscore t opcode pop. Yeah, that's what was there. I'm expecting it to fail at this point. It does fail. So we needed both of those fixes in. So remove it. There we go. Now let's go back to our test and remove this cout where we pronounce it. And you know what? We can do This can be 5, and this can be 5, and that can be a 2, and there should be now 5. Oh, wait. 3 high and then 2 high. That's what we expect. And it's still passing. So we know that calling it works with... Now we can call functions more than once in a row. And we know that we can call them with different arguments. That's working. And yeah, that fixed those two problems. Okay, still haven't got recursion yet, but that had to be fixed first. So we're going to see. So git commit, and what is our message? That we to related function call bugs. Keeping which successive function calls. I think that works. Okay, so that was the first thing. Now, there's one other thing I want to do, and that is in the source program dash execute. And when we go into a function, so no, that it should be call func. There we go. We make sure that the... Oh, and I guess I need to edit tests as well. And what we're going to see is... we don't know what to do. That's fine. Nope. We'll say clear the stack. Yes. And what are we clearing it of? Clear the arguments from the stack. All right. And what is that going to look like? For what is this called? I'm trying to remember. I don't. So this is the type is, if I just look at the source AST node function declaration. At the compile. There, u integer underscore t. That's what I needed on that line. Yeah. So u integer underscore t, I is equal to 0, I is less than, and oh yeah, there was another one right here. We didn't we didn't do the stack check. I remember saying that, but okay, we'll get there. Argc is what I'm looking for. I is less than argc, and then plus plus I, and all that we're going to do is stack dot pop back. Okay, and that's just cleaning it up. And we should also have this stack check here, stack check of 1, and that's just for making sure that we're making sure that there's a function to pop. And function call an unrecognized type, that should be fine, even though I'm going to I was copying that, yanking it. Why? Because we're about to have to, oh no, it won't matter. I'm going to have to write a test anyway. So let's write a test. Do I already have my tests open? Yes, I do. A very simple test would be something along the lines of we could do this. We could just say it doesn't matter. The point is that we're wanting to call something, and it's A is going to be instantiated as a null, and it should yep, that's fine. And now I want it to be get result, and it should be basically an error. Function call an unrecognized type. That's right. And how do we do this? Error. All right. So we now have, we know that we're safe in this, and we should probably do some asserts somewhere that checks the size of the stack. That, of course, if it's an assert, it will be optimized out when we do release versions. But we'll that'll be in the back of my mind. I do want to do that. We don't need to do that right at this moment. But basically, this gives us a few protections. We now know that our stack is going to be restored if, in the event that I try to call something. We're still not checking yet for the proper number of arguments, and in fact, we can do that right now as well. Well, I mean, I wanted to get onto the recursion, and we haven't gotten to do that, and we're how far in? 25 minutes in, almost. So we'll save that for right now. Let's commit this. Make sure. Yeah. And do like How do you spell the word hygiene? That's what I was looking up. Hygiene. Hygiene. On function calls. Sure. I think that's good. Okay, so we still don't have return statements. That's also going to be, I think, probably a part 4. But we need recursion. How do we get recursion? Let's look at the program.cpp. Okay, let's go ahead and write a test. Okay, vim test.cpp, and we want to what else? I think we're going to need the source for program dash execute. Is that right? Or is it in the compile? When we are executing, we actually don't know the string name of anything. So it's got to be in the compile. Yes. It's in the compile. There might be something in the execute. So this is a AST node function declaration. All right, so we're going to set up a separate thing, y7. And we will call this recursion. So this is our recursion test. Print in times. And it's going to expect some number n. And all that we're going to do is say if n is greater than 0, print n times n minus 1, and then print n. So I should probably pass something in. Stir an n, stir, and print stir, whatever that is. And now print in times, and we're going to print, sure, a dash. And you know what? 3 times. So it's going to call it once 3, then it'll call it a second time with 2, and then it'll call it the third time with 1, and then the 0th, well, so oops, I hit the wrong thing. There. Okay, so print is going to do, it doesn't matter if we put it in first or last. This should work. No, I'm expecting an error. Yeah. Why? Because it tries to call print n times, and that it doesn't know what that is. And that's what we expect it to be. All right. So in the compile, when AST function node declaration, when I'm compiling it, I have access to program, right? And I need to do something to tell it that there is a program at a certain bytecode address that I don't know until the end. So the problem is I don't know where function start is until the end, but I've already compiled the code block. So if I've got something inside of it, yeah. The problem is we need to know, for example, we could have a function name, and this isn't really just a recursion problem. This is a problem of the function scope. And the reason is you know what? I can even prove it. I can write a test case for it. B1. There we go. All right, this is number 2. And we're going to have inside here a function inner. We don't have closure, so we're still going to have to pass it the string and in. Undo, didn't mean to do that. There we go. All right, so this will still work the same way. I should call this P2. And this should be 1. Okay, now I've got that straight. So we've got this function print n times. It declares a function inner that will call print n times. So the fact that I declared print n times, not only as in the above one, when I'm inside the function scope, those 3 lines, it needs to know about print n times. But when I'm inside of this function scope, the inner function scope, it also needs to know about print n times. So that means we need to sort of cascade these this information. That's probably the easiest way to describe it. Cascade that into is that how I want to say it? Yeah, into the inner scopes. And by the way, when we're inside of this inner function, it should know about print in times and its own name, inner. It doesn't. We don't know if it's going to be called recursively. It's just it should be available that if it used inner, then it should just work appropriately. So how can we solve this? I say, Corey, why didn't you have this worked out before? Well, I did. I solved it twice before, but those were I did a lot of things differently those other two times. And in fact, both of those times I did it differently. So the problem is still going to fail. The problem is when we compile the block of a function, that's what this line is, this line 71. It will, in the second example, compile a function that in turn compiles a function. And when it compiles it, it's going to say, well, tell me all of your identifiers. And it's going to say, oh, there's a print in times identifier. And it needs to know that the outer scope. Okay, so what tools do we have at our disposal? Whoops. We've got a program, push environment. And the push environment, this is in the program. Do I have program? No, I don't. That's okay. We can add it. Source, program, not the execute program. There we go. And if we look for push environment, there we go. We have an identifier stack. We have a string stack. And what we need is a function. Yeah, we need a function stack. Well, I mean, everything in the environment that's available, if it's declared as a function, not if we've, because, by the way, another valid thing, where's our tests? B1. Let's do this. Probably should not have put that there. There. This is 7 and 7. Okay, print 2 then 1. If I were to say, for example, A is equal to print 2 then 1 and do A, I should get 3 high. And this test should still pass. Yeah. So it still passes because, again, a function is a value that I can pass around. But if I had a scope, I would not expect A to pass into the scope. I'm only doing function declarations. Okay. So I think when we push back that we should forward the information about the current strings. Is that right? Could that work? Well, there's a problem in, I think, in the order that it's being called, or the order that things are being called in that. So, for example, at the beginning of the scope, if I had a function A and its declaration, function B and its declaration, function B should be able to call function A, and function A should be able to call function B, right? And that means I have to know about them really ahead of time, but we don't know where to jump to. This is it's growing into a more difficult problem the further we look. Depending on how we try to solve this. I could even write a test case again for this one. And it's going to be, again, a form of recursion. So I'll just copy this one. And this is... Nope. I evidently hit the wrong button. And we're going to have a function helper that takes stir and in, and all that it does is call print in times stir and in. So it's really just a pass through, but the point is it's there. And then print in times, instead of calling print in times directly, it's going to call helper. Again, it's a type of, well, it's not pure recursion, I know that. It's just, you know. So it's almost that we've got to collect the, just like we collect the function names, the identifiers, and collect the strings, that we also need to collect the function names. And I'm just trying to think of where we can do this, because the problem is we gather it from the function definitions. And it needs to be almost to the point of, I say, hey, there is one here. All right. I think I have an idea. So in program, I need the include for program. There needs to be a hidden Is it hidden? Stack of mappings of identifiers, of strings, and then Okay, I should talk out loud. What I'm wanting is the ability to be able to compile. So the problem is in our example of this one right here, when I compile function and it compiles its code block, print in times, it just knows that it needs to load that, but it doesn't know that it exists. Yeah. And so, but because it is a function that it's trying to load, is that right? Yes, because it's a function that it's trying to load called print in times, we can kind of flag that information to say, hey, I'm looking for this, I don't see it. And so then when we get down here to print in times, we should be able to say, oh, and I just created a function called print in times. When I get to the end of the code block, maybe, is that right? I'm thinking of going back, so having a queue or a list of things that, okay, it needs to be filled in here, it needs to be filled in here, it needs to be filled in here. So how is this going to behave normally? It's not a function definition. That is this. It's not a function definition. It's a function call. And we're going to call collect identifiers. And it's going to say there's a print in times, and it's going to reserve a place on the stack for something called print in times. And that means that we should be able to pre-populate, instead of an op null val, which is what we currently use to reserve a spot, we could change that to the function definition, but that requires more space than a null val. And while that's not impossible, the problem is I mean, we could write something that could, scoot down the remaining byte codes, but then we'd have to say, and what if something's jumping from here into there, we need to adjust the values here so that it's further. And likewise inside, if there's something jumping, if it's jumping past wherever the break is, that point right there, then it needs to increase its number. But if it's jumping back to a part up here, then it doesn't need to increase its number. Yeah. I mean, it's doable. It's just, and in fact, that's what we're going to have to do when we get to optimizations, because we're going to be saying, remove these opcodes, and so we're going to have to probably be squishing stuff together. But I'm not ready to do that yet. I don't like any of my options here, to be honest. Another option would be, just like we have collect identifiers and collect whatever, we could have a collect function declarations. And it goes through and says, okay, I expect these function declarations to be, or I know that in the case of, let's say, this one here, I know collect function declarations helper is going to be defined and print in times is going to be defined. okay, because those are function declarations. And it's in the environment as a stack variable. And then when I get into compiling helper, well, I know that I need print in times as a variable, and I can say, but wait, I know that that's going to be coming in as a function. So instead of reserving a spot on the stack for a null val, I could reserve a spot on the stack of the size of the function information, which is remember the number of arguments and the target program counter. So reserve 3 spots and push that onto a stack of some sort. And so I'm doing that here, doing that there, and when I pop the environment, by then I will have known where helper is, where print in times is, and I've got a list that, oh, here's all the places that helper appeared, and go in and fill those in. Here's all the places that print in times appeared. Fill that in. I might have to do that. In fact, that's probably what I'm going to have to do. So what is that going to look like? Will that pass through multiple layers? Because we still have this one. We still have the inner and print in time. So how would that work for this one? I would say, tell me all of your function declarations. The outermost will say print in times. Okay, great. Here is print in times. Compile. And it says, okay, tell me about all of your function declarations. Ooh, I have a print. I have an inner. Okay, and it's not compiled yet, but so okay, now I'm inside of inner. Tell me about all of your function declarations. I don't have any. Okay, compile. Oh, I'm calling a function called print in times. Put that on the stack. Hey, this needs to be filled in. Not on the stack, in a list of print in times. Okay. So when it gets done with function inner, it would then try to, it would know where inner is, right? So it would say inside of here, hey, did anybody, was it trying to, well, it would do it at the end of the function, function inner. Can I reconcile any of these? If not, it would pass to the outer one. So when it finished with print in times, it would then try to reconcile. And it might not be until it came to the outermost that it could say, hey, I know where print in times is. That might be the case, but I think it will solve the case of the nested one and the case of the alternating. I think that'll work. We're going to have to write, we've got to have 2 structures. We've got to be able to ask, just like we ask about collecting identifiers and collecting streams. Now we've got to collect functions. Now it's like, do we need the visitor pattern for this? I don't know. I don't like the visitor pattern, but I understand its use. Maybe. But we're going to have to... Let's just jump in. Okay? What are we going to do? We are going to program.cpp no. So we're going to need a couple things here. First of all, clear messages, one moment. So what's this going to look like? We need a place to collect, is it just the names at the current level? I think so. So this is going to be a vector of strings. Is that right? Or is it a vector of sets of strings? Call this I don't even think it's a vector. I think it's just a set of strings. And that's going to be called functions declared. Okay, now we need a map of no. A string, and that will point to a vector of integer t's, and that is going to be our function I mean, this is basically our declaration. Or how about this? Stack declaration. Function stack declarations. Okay. I can live with this. So what is this? This is going to be declare I think this does need to be a vector. In a previous or the current scope. Yeah. Okay, and then this is going to be, this is for each function name a list of bytecode addresses that need to be replaced by a function definition. Okay. Now we need to do we need getters and setters for this? Probably. Set jump. So we're going to have to also have a set function target, or a set function, set stack function thing. And for right now, I think that we're going to just make these we'll make them public. Why? Just to get this going. All right. So functions declared and function stack declarations. And all I'm going to do is, for my own knowledge, is, you can see here, I just want to copy these and put them kind of like in a little note to myself off screen. That way I don't forget what I wrote. Or forget their names, really. That's what I want. All right. So what's this going to look like? Now we need in the program.cpp. Is that right? No, but in the push environment in pop. So what do? We need to now take these into account. So we've got our functions declared. So if we're going into a new environment, we want to have all of the previous functions declared added into it. But okay, so we're going to say if functions, well, I just always use this functions declared dot size. So if there is a size, then this functions declared push back. And what am I going to push back? Well, this functions declared dot back. So I'm copying whatever's on the back. Else push back and should be empty, and then AST collect function declarations. And pass in a program, which we haven't written this collect functions declarations, but that's okay. So this is what we would expect. And then if what about this function stack declarations? We just need a new one of those. So this function stack declarations dot pushback and an empty one. I'm hoping it'll let me use that syntax. So let's add a few. So this will be forward all of the previous function declarations. Okay. And gather any new ones in the new scope. That's fine. And this one is going to be prepare to... No, I don't need to push back anything. This is a map. So, nope, don't need to do anything. All right. So that is what happens in the push environment. What happens in the pop environment? This is where it's going to start getting messy. So let's do this with pseudocode first. And what's the goal? This is not enough information. This is not enough information. So I've got a string, and right now I've got the standard a vector that contains a t. What is the point of that? That is everywhere. That is the yeah. I know that didn't make any sense. Made sense in my head. So the goal is to say that at function stack declarations sub print twice is equal to, and it should have, or a vector of, I mean, this is not C++ code. This is just, I should say, at 48 and 72. And I should be able to go through that and say, well, has print twice been declared? So how do I know if it's been declared or not? So this is just functions declared, but that's not really, that's more like let's change this to functions collected, because then we could also have a map of strings for that's the function name, and then I need the two pieces of information, and that is the argc and the program counter. So it would be a standard pair of, what is the argc? U integer t, well, to Tang, U integer t followed by a second Tang, U integer t. And so what's going to happen is, once I know this information, it needs to be added. And does that also need to be a vector? And so this should be functions. I think this should be our functions declared. And it needs to be a vector of this. Yep. Okay, so I need these three. So I'm gonna functions collected, which is just collecting for each level all of the strings that are promised to exist, right? These are function names. That's step one, collect all the function names. Step two is, as we are compiling the functions, they fill out functions declared with the two pertinent pieces of information. And then step number three is, when we pop the environment, it will go through and all of the function declarations and say, where's I want to there, and say, for example, do I have an entry for print twice? If so, at 48, fill in the two pieces of information that's missing, and at 72, fill in the two pieces of information that is missing. And then I can remove that entry of print twice because it's been taken care of. Yeah, that'll work. Step one, collect everything. Step two, as we compile functions. Well, okay. Step one, collect everything. All the declaration names. Step two, as we, well, it's not a data member here, but as we're compiling everything, reserve a spot on the stack for this information. That's fine. Step three is sorry, my brain stopped working. Would be then as we're compiling functions, they report back to us, hey, I exist in a certain place. And then lastly, step four would be filling in all of the missing. Okay, yeah. That's the goal. Oh boy, this is a lot harder than I thought. I should have prepared ahead of time, I think. Let's go back to our pop environment. I can go ahead and write this. Try to fill in function stack declarations. What is that going to look like? Well, we're going to say for auto ampersand declaration, and we're going through this function stack declarations. Okay, go through that, and if function stack declarations, and that is going to be declaration.second. So there's a first and a second. The first is going to be the key. The second is going to be the value. So I'll say for auto amper, well, it's not, it's a number, so bytecode of declaration dot second. Okay, and now I'm going to say this so we did have so we're in number 3. Let's look at number 4. We've got the set jump target. We're going to copy that just for a moment. Instead of set jump target, we will, I just want to see what it looks like. Set function stack declaration. Yep. And what are we going to set it with? Well, first we need to make sure if functions declared dot count declaration dot first. Okay, so what this is doing is, and yes, I'm about to write this as a comment. That's just for me. Okay, so to look in, okay, so that is function stack declarations. Of function name and vector of bytecodes. Okay, that's fine. Now, we'll say functions declared the function was declared within this scope, so we can set the bytecodes to the correct value. And what does that look like? We're going to go through each bytecode, and we're going to say this call set function stack declaration whatever, and it's going to be bytecode. And what's the order? Include where is it? Opcode. That's fine. And in function is the argc and then the target. Okay. Argc. So what is that going to be? Declared. Declaration dot first. Okay, so here, let's do this. This is just getting ugly. So auto ampersand function name is equal to declaration dot first. Function name, okay. Function name dot first. That is, yeah. And functions declared is a vector, so it needs to be function declared does it need to be? Sorry, yes, I'm arguing with myself because my thought is once we've done this, we'll have it'll be in the outermost. So yeah, it doesn't have to be a vector. It can just be a map. So that's fine. So it doesn't have to. I'm changing my notes. This was a vector. Now it's just a map. So functions collected is, that does need to be a vector of set of strings. But functions declared, once they're declared, then we like set all this information, and that's fine. What about this one? Function stack declarations. That's telling us where they are. Okay. Function stack, yeah, that's an example. Okay. So I don't think I need to do anything of this. Functions declared. Oh, wait, no, wait. This should be functions collected. because it's this is kind of forwarding the other information. Yeah. Okay. Push back, and we're making a copy of whatever's at the back, and it's a set. Otherwise, push back an empty set. Okay, that's fine. Now we're here on the pop. We want to try to fill in the stack declarations. So we're going to go through the function stack declarations, which is a map. Okay, that's fine. The function name is function first. Okay, so now we say if we have an entry for that name, then we're going through each of the bytecodes listed in function the declaration second. And we're going to set that bytecode to whatever's in function declared of the function name dot first, and then functions declared function name dot second. Once that is done, then we can C++ vector delete. I want to know how do I, is it erase? No, this is, oh, I said vector, I meant map. Is it also erase? Yeah. Erase. That's fine. So that is so I don't want to erase it. So why? Because I'm iterating through it. So I think I'll say function name dot, and so instead of erase, let's go back to the vector documentation, and instead of erase, is there just a clear? I believe all elements from the vector. Okay. Dot clear. So we'll empty it. All right, so what's going to happen? Now, we try to fill in the stack declarations. So it's a key value pair. Okay, we get the function name. We say if that function has been declared now, then we want to go through each of the bytecodes and set the bytecode with the argc and target. And then, after we've done that with all the bytecodes, remove the bytecodes because they have been filled in. Okay. And then last, so are we using functions collected? All right. I do believe that is correct for popping the environment. This always scares me because that means we're writing a whole bunch of code without being able to test it incrementally. The moment I hit save, it's gonna tell me I've got problems because I haven't made the right changes in our program .hpp. Let's do that. And this is the argc. What is its type? Well, you integer t, and this is going to be the target PC. Set the stack details of a function declaration. Sure. Of the function opcode. argc, that is going to be the argument count to set. Param, not argv. Target PC, that is going to be the bytecode address of the start of the function. Okay, doesn't exist yet, but we'll do that in just a moment. All right, push environment, pop ident environment. Let's do these. So what is functions declared? This was actually not functions declared. This is the collected. This should be the names of the functions that are declared current scope. That's fine. And then function stack declarations. That's fine. And then we have one more, and that is the name of a function key value pair of the information. The key is the name of the function. The value is a pair of the argc value and the target PC value. And what is that? It is a standard map of standard strings of followed by a standard pair of, I don't need Tang there, but u integer underscore t, u integer underscore t. There we go. Functions declared. Oh boy. A lot of stuff there. Need a semicolon. Got it. Everything should be compiling, even though it's not done yet. Just want to fix any compile errors. Okay. Collect function declarations doesn't exist on our AST nodes. We're about to change that. So let's edit source of AST. No, our include for AST node. And we've got the collect identifiers, collect strings, and now we will have compile a list of, what is it? The names of functions that are declared in this scope. Param is program, the Tang program that is being compiled. What did I call this? Collect function declarations. Program ampersand. Program doesn't do anything to me, so const there. Okay, now it's going to complain that it's not created yet, so we need to create a dummy one at least, and that is going to be in our source AST node. Just copying that so that I can do okay, that should fix that compile problem. It's not doing anything, but we'll get there. Oh, hey, sorry, wasn't paying attention. Set function stack declaration. Oh, yeah. We haven't written that yet. Shall we do that? Let's do it. So that's going to be in our program.cpp, that is in buffer 3. Add identifier. Set jump target. And it's of type bool, right? Yeah. Program set function stack declaration. And what did I call these? Should have just done that. There we go. All right, so what all needs to go in here? If minus how many? One was, it should be -2. -2, return false. In fact, not a jump instruction, but a function declaration. How do we do that? We will say if this bytecode sub opcode address does not equal is this what we normally do? Opcode function return false. Okay. Set the instruction. All right. Okay, we're compiling. That's always a good thing. Now, what are we missing? Well, in our AST nodes, so let's open that. Number 7, we've got this collect function declarations, but we need to add that to the source AST node. How about function declaration? Yeah. And just kind of put it at the bottom. And this is no longer going to be maybe unused. There we go. And let's do something. Program dot, and what is this going to be called? Well, functions collected dot back, because it's a stack. And how do we add something to a set? There we go. Come on. Insert. Insert, and what are we going to insert? This arrow name. Simple enough. Oh, it's an AST node. Yeah, whatever. I need to add this to the HPP file as well. So edit the include for the AST node function declaration. There we go. And const override. And now okay, compile should go all right now. And we need to add the same thing, because the only place that a function declaration can happen is in a code, is in the body of some code. Yes, so we need to edit the include for the AST node code block or block. And edit the source for AST node block. And all that I'm doing is I'm yanking this, and now code block. There we go. And instead of AST node block, and for the collect strings, just pass it on down. Now let's again make sure nothing is giving us any weird compiles. good so far. And all right, and that's just sanity check. Make sure that I just haven't missed anything. But it wouldn't give me any errors. But again, better to be safe than sorry. Now, so what of our list is missing? We are, in theory, collecting the functions. When a function is declared, so when we're compiling the name of a function, we need to add that information to this function's declared map. So let's go into, do I already have this up? For an AST node function declaration.cpp. And we know the name, and do we know where it starts? Function start, right there. And where's the argc? Oh wait, where's the function thing? Function, where are you? Oh, it's right there. This is the information that we need. Okay. Auto. That is not the... Is this right? Function should have... Yes, this is the number of things it needs to pop. So it's not just the argc, it's the... Well, is that right? Again? I don't think this is right. Let me, well, this error arguments dot size. Okay. Yeah. because that's supposed to be the number of arguments that we're pushing in. Not that. Now, it was correct to put it here for the return because that's how many things it needs to pop off. But there. Okay. So we need to about this function. Okay, and that would be program dot functions declared. No, not functions declared. One, two, I need four. That's what I wanted. Sorry, I don't remember the. I'm getting tired. Get bytecode dot size. Program dot get bytecode dot size. Program dot get bytecode dot size. Okay, and that is the next one. So this now is function declaration address. Okay, what is our argc? That is going to be the this arguments dot size, and then function start. Now the only remaining question is, should this be before or after pop environment? I'm going to put it at the very, very end. And that should be fine. Now I've realized a mistake in thinking through all of this. I put the collect functions collected. That's the names of them. Is that right? Sorry. What I'm thinking of. What? Oh. So what I'm thinking now is what is this functions collected really representing? Is it representing functions that are declared or functions that are called? Makes sense to be functions that are called. Yes. Okay. No, we're good. No, wait. Sorry. Said it wrong. Functions that are declared. Yeah. So no, I put it in the right place. So now what all parts do we have? We're missing one big part, and that is when reserving a spot for it on the stack. And where does that happen? Let's go to the program.cpp for the compile. Program.cpp, that is buffer 3. There we go. So all that we do is we call the AST node compile. I wonder what in the Bison, a program that is just an expression. Okay, there is. What I'm wondering is, what if our expression is a is equal to 3 plus whatever? Sorry. Program.cpp, buffer 3. This parse. Oh, this compile. Where's compile? The next one. That's what I wanted. So this right here. Reserve spaces on the stack for each variable. Should that be part of push environment? What I'm getting at is so 3 and function declaration, that's 8. So we're going to be going back and forth between these two. When we compile, no, that's wrong. 3 and 2. when we compile a... No, this is a function. Well, still, we have to reserve the stack positions. Okay. For any variable in the body that is not in the arguments. All right, so here's what I'm thinking at the moment. At this point, right now we've been doing a null val. But what we really need to do is go through and go through the arguments in order. And that means, well, skipping the arguments.size, right? So, not the string literals. But what is the order? Well, I know I'm not giving a very good description. The problem is get identifiers dot size. The identifiers we just add right in the order that we find them, and the program identifiers is just a set. No, wouldn't be a set. That we have to know the size, so it's a map of the ordering. And then what we need to do is we need to say, basically, if we're reserving a spot for something called print twice, instead of saying opcode null val, we need to say it's a opcode function and 2 empty spaces. In order to do that, we need to know the order of the identifiers. And the order of the identifiers is the arguments, first the 3 arguments, and then the identifiers. So, what's in program? What's in the identifiers? In order to answer that, we need to go to program.h. Buffer 4. Here we go. Identifiers to their stack locations, and we have a string to size. Okay. So when we push an environment, we're in the program right now, push an environment, for the identifier stack, we push back a new one, an empty string. Now we collect all the identifiers, collect the strings, and forward, okay. Where do we put things in order? Where do we guarantee that we're... Sorry. Is it a function declaration.compile? No, the collect. Yeah, so when we compile it, ensure that the arguments are listed as identifiers in the order that they appear. That's fine. So if we get identifiers and start at the ith one, well, the argument size, because the identifiers are already present, and because we called add identifiers with the number, we know that if there's 3 arguments, the first 3 identifiers are those arguments, and those cannot be, those won't be these functions because of the scope naming. But for everything else, what is the identifiers? The identifiers are a string, and so its name in identifier stack well, what's the order? We would need to know the order of the identifier stack. Well, we can do it. We can do that. It's just it's ugly, but we may have to do it. Okay. Oh, this is program. I'm in the wrong place. So in order to reserve the stack positions, say first get a vector of stack names in the correct order. Okay, so we're going to say vector of strings, and it's going to be identifiers of size program.get identifiers dot size. Easy enough. Well, it would be if I had enough closing parentheses. There we go. And now all that we have to do is for auto ampersand I in program.get identifiers, little sanity check, we'll say if I dot second, that's its position, is less than identifiers dot size. If that's the case, then we will say identifiers sub I dot second is equal to I dot first. So basically it's a flipped, well, not really a flipped, because flipped you think map, but if it had A2 B1, we'd get a vector of B in the well, zeroth, sorry, A1 B0, B in the 0th position and A in the first position. And yeah, so that's second. Second, add an entry for each function. No, each identifier. If the identifier is a function, name, then leave enough room on the in the bytecode. The arguments will have already already been placed on the stack by the calling code. So they can be skipped. Okay, now we can say identifiers.size, and now if need to go back to documentation for a set, does it include something? And I believe that's going to be count. Yeah, just making sure. Yep, count, just like map. Okay, so if program dot functions collected, and that is a vector of dot back dot count of identifiers sub I. If that's true, then that means this is a function. Program dot add byte code uinteger opcode function else this is just a standard value. Okay, and after we've done that, record the fact that this will need this bytecode will need to be populated later once the function details are known. Okay, how do we do that? Well, we say program dot function stack declarations of, and what's the name? That is identifiers sub I. That will be a vector. And if it doesn't exist, it should be created as an empty vector. So we can say dot push back, and the opcode location. Auto location is equal to size. Okay. Push back. Opcode location. What errors do I have? Identifiers dot size. Yeah. That's not a function. We have an infinite loop, folks, right here. How do I know that? Well, I'm glad you asked. Give me just a second. I was killed. Well, I was about to pop open a window and run htop. But, okay, that's fine. So, now we finally get to debug. And you say, Corey, finally? Just now? After 2.5 hours? What is it with me in these long, crazy long videos? I'm sorry, that's... honestly, that's how programming works. You know what problem you need to solve, you have to sit and think about it. And yes, I did sit and think about it since the last time, since the last video. And it just happens that I thought I had it worked out, and then as I sat down, I was like, no, there are details I didn't work out. And so, okay, that's what we've got to do. All right, so in our test. Ooh, there we go. Sorry, it wasn't on the window. So what am I going to do? First of all, we know that none of our recursion stuff is going to work. So I'm just going to comment it out. And do let's see what we get. Okay, so the good news is by adding all that extra code, we didn't actually break anything. So now let's see, where could the problem be? This is our print in times. This is our standard whatever. And we've got null val to represent print in times. That should be right. And a string, that's fine. And jump 33. So 33 is the end of it. And function that starts at 2. Oh no, not starts at 2. starts at 6, but with 2 arguments, and that is correct. Okay, we poke that into 0 and pop it. Now we peek at 1. Why? Because we're pushing on an argument. Integer 3, that's there. Peek 0, that's print n times. And call func 2. Oh yeah, we're passing in 2 values. Okay, so call func 2. So this function, we know it's going to go to 6. And look at that. This did not get populated. Function 0, 0. And what that means is that when it comes time to load this value, print n times. So by the way, good news, that means we did catch the fact that print n times, oh, did we? Is this function 0, 0? Oh yeah, because string and n are passed in, so those would not have a reserved spot on the stack. It's expected that they're already there. So print n times is the only identifier. All right. And so it 0, 0 and peek 1, that should have been the n. And integer 0, is it greater than, yes or no? Okay, so all of this is correct. Even this peek 2, that's going to be loading the function 0, 0. And we're calling it but what that does is it goes to location 0. And then that it's like it's starting from scratch. So that's why it was an infinite loop. I figured that was happening. Now we just have to figure out why this number 6 did not populate. Okay? Let's figure that out. So now we are going to all of this stuff. And what I'm going to do is I'm going to say cout name identifiers sub I. And we should get print n times. Yep. So that came through. All right. So now this is the function, blah, blah, blah. Let's go to the pop environment. And that's going to be in program.cpp. Yep. Where we want to try to fill in these functions. So for each, first of all, did we get here? Function name. There we go, we're compiling. Did we get a function name? Yeah, we got it twice. That works. Now, what's in functions declared? it was declared. Sure. Was never declared. Okay, so this and then functions declared. So evidently we don't have that ever. Oh, because when did we add it when creating a function? That's a very good question. Functions declared. Yeah, we did that. Did we? Yeah, this isn't where this should have happened. Wait, am I in the right function? Yeah, I'm in the compile, but what I should have done, I'm pretty sure this is wrong. This is, I shouldn't be setting it. I should be saying program dot functions declared, which I had my little cheat sheet for what that was. Functions declared. No, that's right. Functions declared. Yeah, I never wrote this. I know I didn't. Okay. Functions declared. Program dot functions declared sub and then the name, which is this arrow name, is equal to a pair, which is the this arrow arguments dot size, the number of arguments, and the function start. Do you like that? Will you compile that? Unused variable function, fine. .105. Whoops. Trying to move up and I'm on the wrong window. Yeah. I bet I don't need that anymore because I was using that completely wrong. And now, look at this. Let's see. Yep, it pushes on a 2 and 6. I bet this will work. Oh, I think it's gonna work. I think it's gonna work. There. It failed. But it didn't. It did fail, but what it did not do is it did not error out on us, and it didn't go into an infinite loop. So believe it or not, this is progress. And looky here, we got an it was declared once, so and it did get filled out, whereas earlier, not this one, the one previously, it did not. So and it got created with the same information, 2 and 6. All right. So now there's something else happening. It may actually be a stack issue. We'll see. I actually like this solution now. I know it's a lot of back and forth, but I do like the approach overall. So when executed, it gave us nothing. If I do cout p1 dot or star p1 dot get result, there should be a result now. And over here I gotta hit Control Q because there. Function call on unrecognized type. Okay. So it didn't like that. Okay. So let's figure out what I was doing a function call on. So call func is fine, and we peaked 2 before we called the func. Now, well, the first call func is on peak 0, and 0 is a null value, but when we created the function, so we jump to 33, 33 creates the function, pokes it in 0. We peak it, and we call the func with 2. That's fine. And so that's going to go back to 6. Okay. This is... I'm looking for the end of it. There we go. That's the entire function. And we poke in a function 2.6. But we're expecting there to be 2 things on there already, so 0 and 1. And when we call func, it's because we peaked 2. That should be... Okay. So, let's figure out where it's happening. How do we do that? We're going to edit the source program execute. Yep. Okay, that's fine. And we're going to go to, or look for function call on, that's probably fine, on unrecognized type. And this is the only place that it exists. So what is the unrecognized type? Star function. So what we're going to do is say cout had to hit Control Q since I highlighted something. There we go. Function.dump. It doesn't... Oh, the garbage collected has no member. So why? Because we had to use an arrow to get to the computed expression inside of it. Error, don't know how to subtract these values. Is that really it? Don't tell me that that is it. Don't tell me that that has been If n is so string n string n string n minus 1. That doesn't make any sense. Okay. So I'm going to delete this because we now know what it is. And where is subtract? Right hand side, right hand side. We're going to get a lot of these, I think, because we're running all the tests. So just ignore that. We're only looking for the last one. There we go. Minus and 1. Wait. 3 1 2 1 1 1 minus 1? Yeah, because if I replace it with that's not a good thing. Let's do a capital X. It's probably going to say X and 1. Yeah. Why is it doing that? Okay, by the way, this is kind of good news in that we know that it at least got called with a 3-1 and then a 2-1 and then a 1-1. But when it failed, why did it do X and 1? So, let's look. Subtract peak 2. Oh wait, because that's leaving something on there. Peak 2. Call the function. It looks to me like our stack is not acting correctly. And we're only seeing it now because this is the first time that we've gotten to do recursion. So oddly enough, I think most of the recursive stuff is working. It's just now we've got an error with our stack. Okay. So, by the way, we've got all that stuff, yeah. Just doing a little bit of cleanup because I know what I want to do, and I want to. I just closed out. I did not mean to do that. That is unfortunate. Where is that print end times? Okay, so that's working. Just making sure we're removing everything. And I am going to exit again. Why? Because make file. Here it is. Filter is equal to function dot recursion. There. Now it only ran the one. Why do I care about that? Well, now, just so I can run this and compare them side by side. So what I'm going to do here is I want to know the state of the stack after each operation. So that's the switch. And now the state of the stack after this operation is we're going to cout 3, 4 I minus fp and then stack sub I dump, and then an inline. And now just gonna trace. So after we run 0, null is on the stack. After we run 1, there's an X on the stack. Number 4, jump to 33. Nothing's changed. 33, function 2.6. It's a compiled function is on the stack. 38, 33 is put it on the stack. 36 is poke it, but it leaves it on the stack. And 38 is we pop it. So, okay. 39, peek. So we've copied X. 41 is put the 3 on there. 43, put the compiled function back on there and call the function 45. After 45, we've gone into it and... Okay, this is not quite right. Why is there a... Okay, so... Okay. I think that was just a red herring. Let's go back up. So 43, we peek. 45, we call the function, and the only thing that should be there is a 0 and 3. Okay. We go back to 6. After we run that function, there should be the compiled function. x3 compiled function. Is that right? Yes. 9 says peek 1. That's the 3. Okay. 11, integer 0. 13, greater than, so it's true. And notice it popped them both off, so it's true. 14, jump if false with a pop. So it popped it off, but it was true, so it's not going to jump. It's going to go to 16. Okay. 16 says peek 0, which puts x back on. 18, peek 1, so 3. 20, put the integer 1. 22, subtract. We got a 2. 25, oh wait, 23, peek 2, which is the function that we're calling. And now 25 is call func, which puts us in with an x and 2. Okay. So I'm going to scroll down to the 25 that should be x and 1. That's fine. 25 is x and 1. There should be another 25 that's x and 0. There is an x and 0. All right, so we're going to see what happens here. We go to 6, function, with the 2 and 6, that puts the compiled function on. 9, peek 1, we're fine. 11, integer 0. Okay. 13, greater than, it's false. So 14 is jump if false. So after 14, it removed it, and it went down to, should be 31, which is, oh, insufficient stack depth. 31, what's 31? Return. And there's 3 things. What? Return with 3 was correct. Should have only been return 2. Okay. Okay. This is good. Return, return. Where's the return? Return is the total number of things that it needs to pop off the stack. 3 was correct because there are 3 things on the stack. So the bytecode B2 stack check. I don't think it should be pop. Oh, there is expecting to have a return value. That's the problem. It's supposed to have a return value. So my if is not leaving a return value now. And I just never caught it before. It's a bug in if. Okay. So if the condition is false, wait, we compile whatever is the condition. Just undoing all of my code here. Now, I still want to have this corrected. Okay, so we got here, but we shouldn't have. All right, so the change I made was on that was just semantic. It wasn't a big deal. Okay, so am I leaving something on the on the stack? Jump if false. No, we're not. We've got to put something on. So condition false jump. Condition false jump. Jump past the then block. And that should be the current size. But I need to leave something on the stack. Program dot add bytecode. You integer t. Opcode null val null val. So, what is this saying? if it's false and there is no else block, put a null on there, on the stack. Okay. If it's false and there is an else block, I don't think this is right. Clean up the stack from the then block. In fact, that seems really messy to me. Okay, so the then block leaves something on the stack. Yes, it does. But if the condition is false, we're jumping past it anyway. We don't want to clean up the stack. We want to leave it on it, and we're jumping somewhere. It's fine. Add the else block, set the jump location. The else block is going to leave something on the stack. Now we set the jump locations. So the I'm thinking, did I already solve it? But all right. So condition is false. It goes past the then block, goes down here. It just says, hey, the condition false is going to jump to wherever I am, and we're going to push a null on there. That's fine. That's if there is not an else. If there is an else, it's going to record where the then block. Oh, so this is to make the else, the then jump past the else. Yes. Now the else block is going to start here. It leaves something on the stack and set the condition false to jump to the else block start, and set the jump target of the then block jump to be I don't think this should be +1. There. Because the then block is now going to jump to past me. If you see it, here it is. Remember, I changed that to X's and we got 3 X's instead of 3 dashes. Now, just have to find the right window. Not that one, that one. For this one, we were filtering for recursion. No filters. That's the only one that failed, is the last one. And it's supposed to fail. So nothing is broken now. So that was the problem. Our if statement was broken. Yeah. Okay. So I'm just editing the make file to remove the fact that we're filtering for that one test. Nope, that's the where are the commands for the test? For the test, where's the test? Here it is. All right, and I'm closing that window. Okay, now it's back down to a manageable size. So, what do we need to fix? Sorry, there's a fan blowing on me, and I have got to have it, but it bothers me at times. It's like, okay, so I do want to point out that on this one, so what we want to look for is the 32, the return. So we're going to scroll down 32, 32, 32. Because this is calling stack values. Every time we see a 6, it's calling x and 1. The next time we see a 6, it'll be x and 0. Yep, x and 0. And now we'll see it should jump to 31, 32. This is the return. And what did it do? Well, it returned us to the previous context, which was 27, 28, 30, 31, 32. Return us to the previous context. 27, you see the, let's look at this 32. It was an x and 1. And then the next time we see a 32, it's an x and 2 because it's working its way back up the stack. And then 32, there it is, an x and 3. And so now this is the, I believe the parent context. 30, 31, 32. Yep, and it exited it, and all right. Now, let's remove some of this. All right, so we're still, just removing everything, all of our debugging stuff. And now if we replace this with a dash, it worked. And that, so the dump bytecode, we can comment that out. Let's see if P2 is working. It is. So realize P2 is, so P1 was just a standard recursion. P2 was the function declaration of print names being passed into another function. And now we're going to try for P3, which is where they are kind of, you've got this weird helper calls print in times and print in times calls helper. If it works, please, please work. It worked! Yes! You have no idea how happy I am. Because I'm looking at the recording time and I'm probably have cut this down some for you. But I'm at 3 hours and 41 minutes. So, but if you add that up, that means it took 3 hours to do the first video. 2.5 hours to do the second. I'm not even going to count the 1 hour because where I was fixing the fact that the second video didn't have any audio. So 3 hours, 2.5. That's 5.5 hours, and then this is 340. 9 hours to get functions working with recursion and stacks and debugging. It's a lot of work, but it's working. Who cares? Okay, so let's figure out the damage of all of this. I think the if AST node if else, this needs to be its own thing. AST node if else and get commit. What is it? The message is bug fix AST node if else not did not always leave something on the stack. Seven insertions, 7 deletions. Okay. It's fixed. Hey. Let's look at everything else. All right. Recursion supported. Declared functions. Now, what do we want to say? To child scopes. There we go. That makes sense. 180 lines for that. But again, it works. Make sure there's nothing else. Okay. Sorry, it's been almost 4 hours since I started this. What episode are we on? Episode 38. Recursion. 38. Zero 038, and the message is 038, not Origin Master, episode 038. $47.21 of code and 1,800 lines of comments. Again, bigger is not better in this case. I mean, ever. It's just something that gives us an idea of, yeah, we are making progress, we are working. But we've got Recursion working, and it was a big lift. It was a lot of work. Debugging, oh my goodness, and then it probably spent an hour figuring out that there was a problem with the if statement. And yeah. But it's done. And I'm happy about that. For now, we're gonna go and I've got to edit this now, edit this video, so I'll try to make quick work of it. And thanks for joining me on it. And as always, have a great day. Bye.